So I'm about to start pulling the condenser from a 2011 Toyota Camry SE.
So if you need technical information on Toyota, you need to go to techinfo.toyota.com. Create yourself an account, and then you'll need a subscription. Subscription prices for 2 days is $20. For most significant repairs, that's no big deal. $90 for a month or $500 a year. This is what you'll need if you have a vehicle that's newer than, I think, 2011. Once you have your subscription, you'll be able to see information like what I have here. These are the different parts that go into or need to be removed during replacement of a condenser. Again, more information on the removal procedures for removing the condenser, and then installation of the condenser. Now you won't need every single thing in here. Like, for instance, it talks about installing the new cooler dryer. Well, the condenser I bought I didn't have to do this because they just seal the condenser and have the dryer already installed.
So if you don't, get yourself a pair of gauges like this, and you need to hook it up, and you want to get a little bit of a charge in your AC system so that at least it cycles. Make sure you've got a can tap. Make sure you're using R134A. Don't use the stuff with stop leak.
If you don't have access to someone who can recover the refrigerant, you can just let it out. Technically, you're not supposed to, but no one's going to come chase you over it. R134A is not known to be toxic. One thing you do have to note is that it's not oxygen, and so if you can't do this in an enclosed area where the R134A can just sit there. You should open your garage door. Don't let it out in an enclosed space to be safe, to be on the safe side.
So once you've cycled the AC system for several minutes, Toyota wants you to recover the refrigerant. You have to be professional with a special machine to do that. So if you can have an auto mechanic friend help you out, or you have a shop that can help you, that could be useful. Next, they want you to remove what's called the air intake duct seal, which should be like right here. So I don't have one, not on this car. Maybe I should get one. We'll see. Next, we're going to remove the air duct passage and get it out of the way. We need to remove this whole cross member here. I'm not sure how much of this I'm going to have to remove. The Toyota instructions say actually quite a bit, but if I can get away without taking it all out, I'm going to. Next, we take out this cross member. Next, you want to remove the front bumper assembly. There's another video that I'm going to link to down in the notes that shows you how to do this. That's a quite good quality, so just use that. We then remove the condenser. This is the condenser right here. You can see there's a bolt here, and then two connections down here, and I believe there's two bolts at the bottom. One here and one here. No big deal. Pretty easy. Okay, so I started putting the condenser back in. Okay, so I put the new condenser in. I already put this cross member back in, but there's a bolt under here, bolt here, bolt down here and here to put back. When you reattach the lines down here, there is O-rings. Make sure that you use some oil on those O-rings. It just helps the O-rings move around more easily and less likely to stick and rip and things like that. It's important to oil the O-rings. So once the condenser is back in, you need a vacuum pump and a set of gauges. You need to vac the system, and basically what that looks like is what I'm about to show you. Hopefully you can still hear me. So the vacuum pump's on. You can see that the gauge, I have this port open, and you can see that the gauge is going down in pressure. We want to run a vacuum because we want to boil off any water that's in the system. Since I'm not a professional, I don't have access to what's called micron gauges to measure the amount of parts per million coming out of this system, how much water is coming out. So what I do is I just vac this down for several hours, and I let it hold a vacuum. Right now, it's holding close to near perfect vacuum, and on my vacuum pump here, there'll be steam that comes out of this port. I want to show that, so I'm going to turn on what's called my gas ballast and see if I can get some steam to come out. Well, I can't get any steam to come out. I think it's because I've already vacuumed this thing down for several hours, and I don't think there's anything in my system anymore. But anyway, let me show you the gauge. Here, like I said, I'm almost at perfect vacuum. You want to hold that. Once you've held this for several hours and boiled off any water that's in the system, shut your vacuum pump, or excuse me, I got to close the gauges first. So I close the gauge, tighten that down real good, and shut off the vacuum pump. The gauge, leave it under vacuum and close your gauge. You want to hold this for at least 15 minutes. You don't want that needle to move. If you have more time, I'd let it go longer. It'll show you that you have a closed system that's going to hold refrigerant if that needle does not move. The longer you let it go, if you can let it go overnight, then that'll really show you that you don't have a problem. Now, if you do, the needle does move a little bit, that doesn't bother me, especially if it's overnight. That's because your gauge, my gauges here, this is put on hand tight. This is put on hand tight, this is put on hand tight, and so is this. Yesterday when I was doing this, I had my high pressure port engaged here, or I had this on the high pressure port, and just having so many different leak paths, this went to 0. When I took this off and I just have my low pressure port connected, and I had this just this single valve, this blue valve closed. These are both closed. It held overnight, which tells me my system is good to go. I can put refrigerant in it now. So yeah, anyway, the summary is make sure your system can hold a vacuum. If it can hold a vacuum, it's going to hold refrigerant. Okay, so I've got the system under vacuum. I've got my refrigerant can sitting on a scale. I believe this car requires right around 10 ounces of refrigerant, and there's 12 ounces in here. So the way I like to do it is to zero out my little scale here, little scale I keep in the kitchen. It's normally for weighing food, and just use this to measure how much refrigerant I'm putting into the system. So my goal is to put 10 ounces. So I'm already at 40 psi, and you can see there's only 0.8 ounces that's gone into this thing. Okay, so I'm continue to get more refrigerant into the system, and because it's so, the can gets cold, the pressure doesn't stay high enough to go into the system. So I just shake it and hold it with my hand so it gets warm. And that's good enough. So now I have this closed and I have the high pressure port connected. You can see that we're at about 30 psi on the low side and about 200 on the high, which is about right.
Okay, so I want to explain this graph from Tech Info, Toyota's Tech Info. On the x-axis we have pressure on the high side. On the y-axis we have pressure on the low side. I'm going to be using PSI. Use the other units if you need. So I'm looking at 73, 145, 218, and 290 on the x-axis. So the second number. So when I had filled my system, I had a high pressure side of around 200 psi, and then my low side should have been between 29 and 39 psi, and it was. My blower was on high, so I was in this zone here. So, and my point then in this graph would be somewhere in here, which seems to be in the right zone. One of the things you want to be careful of is you overcharge your system. What you'll see is you'll have a high pressure side of like 290 psi. And then your low pressure still will be around like say 30 psi. And so you're going to be out here. So you've overcharged your system. This graph is one of the ways to check if you've overcharged your system. I forgot to show adding oil to the system. So you're going to need to get yourself some PAG 46, and you're going to need to add about an ounce of oil to the system. Just hook this up. You know, get either guess or use your scale to measure out an ounce of oil. You do that because the condenser had oil in it, and you will need to replace that oil in the system.
Normally, I would show you the temperature and check that it is blowing 30 degrees colder than when it is outside, but I misplaced my temperature gauge, so I can't do that. But if you're doing this yourself, you should see that on max AC with recirculate on and as cold as it'll go, that this air temperature at the vent is coming out 30 degrees colder than what's outside. Yeah, that's what you should do.